So we have the equation 5m equals 20. Again, the goal is to isolate the variable, leave the variable by itself. We have on the left side of the equation 5m, on the right side we have 20. Anytime I have a number and a variable next to each other, I know that that represents multiplication. And in order to remove this 5, I'm going to need the inverse operation of multiplication, which is division. We often show division by creating a fraction, right? We're going to say 5m divided by 5. And properties of equality say whatever I do to one side, I must do to the other. Well, we know that 5 divided by 5 is 1. 5 divided by 5 is 1. And 1m is m, which means that that's equal to whatever 20 divided by 5 is, which happens to be 4. We can check our work to see if it's correct by substituting this 4 back into my equation. So my original equation said 5 times whatever m is. Well, m happens to be 4. So 5 times 4, does that give us 20? And the answer is yes. So therefore, our answer is correct. It checks. Okay, if we want to create a visual for it, we know that an equation can be represented with a balance scale. On the left side, we have 5m. Because I'm using algebra tiles, my unknown here is represented with an x. We're going to think about it as that's the m. And I need 5 of them on the left side. So there's 1, 2, 3, 4, and 5. So I have 5 m's, or x's in this case, that are representing 5 things that I don't know how many items are in there or what it's representing so far. And then on the right hand side, we have 20. I have these in groups of 5, so 20 would be that many right there. Okay. And since that's what we were given in the equation, I'm going to tell the scale to balance. Right? So here we have 1, 2, 3, 4, 5 x's, meaning 5m in this case is equal to 20. Each one of these has 5. So we have a total of 20 pieces here. I often like to think about it as when we're dividing, it means I'm splitting things up. Right? I'm splitting them into groups of one variable in each group. So there's one. I have very little space in between to separate them. Let's see, can I move this a little bit higher? There we go. There's the 5 of them. And so what I need to do, I need to split these evenly between all the 5 variables that I have. So I like drawing lines to kind of help me stay organized. And keep my groups. So I know that I'm going to make 5 groups, and each one of them splits up my groups. Okay, let me grab these and take them out. And now I'm going to put them back, but in a somewhat orderly manner so that every single group ends up with the same amount. Okay. So I can say there's 1 here, there's 1 here, yeah. So I'm trying to split them evenly between each group, right? Each variable. And so far each group has had 3, now each one has 4. There we go. My scale is balanced again. And we're seeing that every single group ended up with 4 pieces in each group. So that means that each x is equivalent to 4. And what that means is that if I take an x out of here, in order for my equation to continue to be balanced, I could take 4 out of here, and we can see that it's balanced. And I could continue to do that until I end up with just a single x and my scale balance, meaning that what's on the left side is equivalent or equal to what's on the right side. And yep, we can see that 1x is equal to 4 pieces. Another way that I like to think about it is I can think about it as this 5m is saying that I have 5 boxes. So 1, 2, 3, 4, 5 boxes. And inside those 5 boxes, I have a total of 20 counters, right? So in order for me to end up with 20 counters, I need to figure out how many are going to end up in each box, right? So I can say, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And the answer is whatever 1m is equal to. Each one of these boxes was representing an m. Therefore, 1m is equal to 4. That means each box would have to have 4 of these counters in order for me to have a total of 20.